All right, good morning. This is for Thursday, and what I will be doing today is visiting the Magic Kingdom, which is right here. And here is Mickey the Mouse holding Walt Disney's hand. Let's talk about more what you're going to be doing today. Um, let's get a graphing calculator, and let's look at this particular graph here. We recognize this is a polynomial function. We're looking at the end behavior, and we see that this has to be an odd degree with an positive leading coefficient. All right. Now, another thing we can recognize are the x-intercepts or the zeros. I see a 0 at 1, I see a 0 at 3, and I see a 0 at 5. And with these zeros, I can write down a polynomial to show this. So it looks like this. I'll do y equals x minus 1, x minus 3, and then x minus 5. Go ahead and use your calculator and graph this function, and you should have the graph seen on the projector. Let's do that again. Notice with this graph, we have odd degree because of the end behavior. We also have a negative leading coefficient. Now, one thing we might recognize too are the zeros. We have zeros at -2, 0, and 3. So then our polynomial will be, let's use the function notation. It'll be f of x equals x minus -2 or x plus 2. Let's see, x minus 0, and then the x minus the 3. Now, let's also note here that it has a negative leading coefficient because of the end behavior that we talked about. So we're going to have to put a negative in front like so. So cleaning this up, we can graph this or write this as, it'll be, let's see, that is just negative x times x plus 2 times x minus 3. I'd like you to go ahead and put this in your calculator and recognize that this is the graph that we have. Okay, moving forward. Now, look at this. What we learned yesterday is if we have a 0 that bounces off, we would say it has a multiplicity of 2, and it looks like this. Notice a 0 of -1 and 2. My factors will be this. I'll have y equals x plus 1 for the 0 of -1, and then I'll have x minus 2 to the second power. The second power of that binomial accounts for the fact that the graph bounces off at that 0. All right, so go ahead and let's check our end behavior. End behavior is such that we have a positive leading coefficient. Go ahead and get this in your calculator and verify that this is the graph. All right, so it's now your turn. What I'd like you to do is take your calculator and see if you can't produce this function, this graph, in your calculator. Think about the zeros, think about the end behavior, and pause this video now, and we'll see what you can do. So, okay, we're back. What you should have done here is recognize that we have a 0 at -1 and 0 at 2. That's going to be x plus 1, but it's going to be to the second. And that's going to be x minus 2 to the second, because both of these bounce off on those intercepts. Now, the end behavior shows that we have a negative coefficient, so we just have to throw a negative in front. So if you were to graph this in your calculator, this is the graph that it would produce. All right, let's try that again. Show me, or use your calculator, produce the graph of this in your calculator. Might need to pause to do that. All right, so here we have, let's see, it's going to be, the zeros here are 0 and looks like 3. So we have x minus 0 to the second, and we have x minus 3 to the second, and that's y equals. The end behavior is even positive, so we do not have to add any other leading number. So we'll have y equals x squared times x minus 3 squared. I think I have one more. Let's move on. Oh yes, this one. Try this one. Notice it's kind of hard to see. Let me identify the zeros for you. There's 5 of them. I see an intercept at -2. I see an intercept at -1, 0. I see an intercept at 1 and an intercept at 2. So pause the video and see if you can come up with the equation for this. All right. So what you should have realized here is that we have x plus 2 to account for the -2, x plus 1, and then times x minus 0, and then I have to have an x minus 1, and then x minus 2. This is a polynomial for this particular graph, except for one more thing. Notice the end behavior is a negative leading coefficient with an odd degree, so we got to throw a negative in front, and this should have been the equation you typed in. All right, so today's lesson, we're going to do section 3.3, dividing polynomials. This is the definition from your book. Let's try to make this more meaningful for you. When you were in 5th grade, your teacher asked you to take, let's see, 27 divided by 5. And then you took 5 times 5 is 25, subtracted and got remainder 2. So if we were to identify the 4 terms here, the 27 is your dividend. The 5 is your divisor. The other 5, I'll circle it. This 5 is your quotient. That's your answer. And then the R shows me that the remainder is 2. So what they're saying here is if I take the dividend, which is 27, if I take the dividend, that should equal the divisor, which we said was 5, and then we're gonna multiply that by the quotient. The quotient we said was 5, so we're gonna multiply that by 5, and then we'll add the remainder. So let's see, we'll add 2. All right. So let's see. Does 27 equal 25 plus 2? Check. That does work out. So what we have here in terms of the notation is nothing more than 4th grade math. It's showing that this is the definition of division using the idea of multiplication with the remainder. What we're going to be doing here is we're going to be dividing polynomials with long division and synthetic. You can pause this video and write down these steps as you need, but let's just jump into an example. So with long division, we're going to recognize, let's use terminology here. This guy is the dividend, and we're dividing by the divisor. All right, so we're going to put the dividend inside here and get x to the 3rd minus 4x to the 2nd minus 17x plus 6, and we're going to put x minus 3 on the outside. Let's see, step 1, perform a mini division. So you're going to take the first term divided by the outside term. So x to the 3rd divided by x is your x squared. They're going to multiply that by the divisor, multiply that by both terms. I get x to the 3rd minus 3x squared. Let's see, what was that next step? We're going to subtract, multiply the term on top of everything, subtract and bring down the next term. Now, when we subtract, I like to go ahead and change the signs and add. And so what should happen here is the x to the 3rds cancel, and I'll get negative x to the 2nd, and then I'll bring down the minus 17x. At this point, we're going to lather, rinse, and repeat. So let's see. We're going to take a mini division. We're going to take negative x squared divided by x, which is negative x, and then we're going to multiply now. It's going to be negative x squared times, let's see, that's going to be plus 3x, and then we're going to change the signs and add. So we're going to change this to a plus and a negative. We get minus 20x. We're going to bring down the 6 and do one last mini division. Let's see, negative 20 divided by x is negative 20, and then we're going to multiply and get negative 20x plus 60, and then change the signs and add. And we get negative 54. So that is the remainder. So the way we're going to write this answer is we're going to take that remainder and add it to the remainder divided by the divisor, so negative 54 over the x minus 3. All right, here's the next example. What we have here is, notice how this is different. Your divisor is quadratic, whereas in the previous example, your divisor was linear. So that brings up a different challenge. So what we're going to have to do here is we're going to have to rewrite this with a placeholder. And what I mean by a placeholder is we're going to account for the linear term that's not there. So let's see, 6x to the third plus 10x squared plus x plus 8. And let's do this long division the same process. We first do a mini division. We're taking 6x to the third divided by 2x squared. That produces 3x. Multiplying this by the divisor, I'll get 6x to the third. That should match up every time. Plus 0x squared, and then plus your 3x. Instead of subtracting, let's change the signs and add. And then the first term will cancel. What we have here is a plus 10x squared, and then a minus 2x. Got to bring down the 8. And then let's see, multiplying by 3x. Excuse me, now we're ready for a mini division. We're taking 10x squared divided by 2x squared to get plus 5. And then we're going to multiply that 5 through the divisor and get 10x squared plus 0x, and then plus the 5. And then changing the signs and adding, see, once again, these terms cancel. I'll get a minus 2x and then a plus 3. I'm finished because my degree is less than the divisor, so the remainder is negative 2x plus 3, and we'll divide that by the divisor of 2x squared plus 1. All right, so here's another example where we are, let's see, just like how we started this video, we talked about this notation here as far as trying to understand what this means. But let's go ahead and form the division. So let's see. The divisor, we have 2x squared minus x plus 2. And notice that the dividend is going to need a placeholder. It's 8x to the fourth plus 0x to the third. We have to account for all those powers. Plus 6x squared minus 3x plus the 1. All right, so let's take a look at this. We're going to do a mini division. 8x to the fourth divided by 2x squared is let's see. That's going to be a 4x squared. Multiplying this by the divisor, I get 8x to the fourth minus 4x to the third, and then plus a 4x squared. Let's go ahead and change the signs and add. So minus plus minus. And I'm going to end up with a negative 4x to the third plus 2x squared. Let's now bring down, correction here. Let's see, when I take 4 times a 2, I'll get an 8x squared. And then when I subtract that, I'll get a minus 2x squared. There we go. Let's bring down that minus 3x. And we're ready for another mini division. We're going to take negative 4x to the third divided by 2x squared and get minus 2x. Multiplying through, let's see, we get negative 4x to the third. Multiplying this by the x is a plus 2x squared. And multiplying 2x by the 2 is a minus 4x. I'm going to change the signs. Plus, minus, plus. And notice it's nice here. This goes away, this goes away. I'm left with simply, all right, so I think hopefully you caught my mistake. I caught it. Notice this is going to be a 4x to the third, and then minus 2x squared. That should be the answer after the first round. Now we have to first now do a mini division. 4x to the third divided by 2x squared is plus 2x. And so now multiplying through, let's see, we're going to get a 4x to the third, and then a minus 2x squared, and then it's going to be a plus 4x. I already brought that minus 3x down. All right, and so then after we change the signs, I get a minus, plus, and a minus, and then these terms cancel to give me negative 7x. Let's go ahead and bring down that 1, and that is the remainder. So what we're trying to get you to understand here is we can rewrite this as this is your dividend. So your dividend is your 8x to the third. All right, so taking a look at this again. So your p of x is here, which is your 8x to the fourth. So they want us to write this as the following. They want p of x is equal to, that's the divisor, which is your 2x to the second minus x plus 2. We're going to multiply that by the q, or the quotient, which is the 4x to the second plus 2x. And then we're going to add the remainder, so plus negative 7x plus 1. And so if we were to multiply these terms out and add the remainder, we will get p of x. All right, so here's the next part of this, synthetic division. It's a shortcut for long division. Synthetic division is the quick method of dividing polynomials. It can be used when the divisor is of the form x minus c. That's really important. So notice that we could not have used that on this example because our divisor is quadratic. We could not have used synthetic division on this example because the divisor is not linear, but we could have used it here on example 1. So here is, let's see, in synthetic division we write only the essential parts. And so let's explain how this process works with a quick, easy example. Just to reiterate, the divisor must have two characteristics. The leading coefficient must be 1, and the degree must be 1, which is simply saying that's a linear divisor. So here's a good example. So let's see. We start by writing down the coefficients of the dividend, which are 2, negative 7, 0, and 5. Notice there is no x term, so I have to count that with a 0. And then we're going to change the sign and put the 3 out here. We start this by bringing down the 2, and we're going to do a process of arithmetic. We're going to multiply 3 times 2 to get 6, and we're going to add that column to get negative 1. And then we do the same process, lather, rinse, repeat. Multiply 3 times negative 1 to get negative 3, and then add that column to get negative 3. Multiply 3 times negative 3 is negative 9, and then add this to get negative 4. So what we're going to recognize here is that these 3 numbers are the quotient. It's 2x to the second. It's always 1 less than what you started with. Minus 1x minus 3, and then your remainder, this is your remainder. So if you want to rewrite this in the form that we've been using, you would go 2x to the second minus x minus 3 plus negative 4 over the divisor of x minus 3. All right, let's go back to that very first example here that we did long division for, and let's verify that this is indeed the right answer. Let's see, the remainder was negative 54. So if we were going to do this problem with synthetic division, which we can because the divisor is linear and it is leading coefficient of 1, I would change that to a 3. And then inside this box, I would put the coefficients of 1 and x to the third, negative 4, negative 17, and 6. Let's bring down the 1 and multiply to get 3 and add to get negative 1. So once again, we're bringing down that first term, multiplying 3 times 1, and then adding that column. 3 times negative 1 is negative 3, adding to get negative 20, and then 3 times negative 20 is negative 60. Adding this gives me negative 54, which is the answer that we just erased. Let's look at another one. Maybe it'd be a good time for you to try this one. Try this example in your notes, and then we'll show you the answer. Just go ahead and try it now. Do this one right there. Maybe we can pause the video. All right, so here we go. 1 goes right there because we have an x minus 1. Your coefficients are 2, negative 4, 3, and negative 1. We're going to bring down the 2 and get 1 times 2 is 2 and add that to get negative 2. We're going to multiply 1 times negative 2 is negative 2, add to get 1. 1 times 1 is 1, add to get 0. So it turns out that x minus 1 is a factor of this polynomial. And so my answer is simply 2x squared minus 2x. I'm getting that from the answers here. This is 2x squared minus 2x, and then plus the 1. No remainder, so we leave it like that. All right, here's the last example. Notice they just give you two in a different form, but I like this example because it reminds us that we have to do a placeholder for the missing quadratic term. There's a 1x to the third, there's a 0x squared, a minus 8x, and a plus 2. And let's bring down the 1 and multiply it and get negative 3. We're taking 1 times negative 3 is negative 3. We're going to add to get negative 3. We're going to multiply the negative 3's to get 9, add to get 1. And negative 3 times 1 is negative 3, add to get negative 1. So once again, our answer is 1 power less than what we started with. So this is a 1x squared minus 3x plus 1 with the remainder of negative 1. So you could write it as x squared minus 3x plus 1 plus negative 1 over the divisor of x plus 3.